So first, let's just take a look at the warm-up problems here. So this is just a throwback to last week, nothing crazy. Find the value of x in each diagram. Remember, I wish we had color copy machines. Those are red, our lines are parallel. Humor me, I know you know it. What special pair of angles are these? What is their name? When you're in a similar location. Corresponding. I know it doesn't ask, I'm just going to jot it down. Okay, 50-50. Are corresponding angles congruent or supplementary? Congruent, so easy enough, we're going to set them equal. I know you guys are great at solving equations. Let's just subtract 21. Okay, and what's 111 minus 21? We're lively today on a Monday morning. You're close on the 80. It's 90 and 90. And hey, this is just me. I always like it, my answer to read x equals. And let's review our properties. What property is that when you switch the sides? There's an S. Symmetric. Hey, why not? Just for fun, right? Okay. So same thing. Here's your parallel lines, of course. We got them. So I'm looking at our angles here, and there's no direct relationship between the 3x plus 33 and the 78. They are not alternate interior, alternate exterior, etc. But this angle is congruent to this one. Why? They're vertical angles. So I'm just going to write in a little 3x plus 33 here. Little vertical angle knowledge. And there is a relationship between these two. What type of angles are these? They're right in a row, consecutive, and they're inside. Okay, so consecutive interior, we got that squared away. Now, next thing you have to know, 50-50. Are consecutive interiors congruent or supplementary? Supplementary. So we're going to add them up. I'm going to scroll this because I don't have much room here to write. I'm going to scroll this up just too far, a little bit. And let's add them up to 180. So I'm going to do 3x plus 33 plus 78 equals 180. All right, let's solve it. Of course, we're going to combine our like terms, 33 and 78. There's some good vocab. Combine like terms. We've been using that in some proof writing. I'm going to subtract the 111. You guys probably already have an answer. And how many times does 3 go into 69? Final answer is 23. I heard it. Got it. Okay, so nothing new, just practicing 2 out of our 4 new pairs of angles, meaning corresponding, consecutive interior. Don't forget about alternate interior and alternate exterior you will see today. So like I said, today has really had a lot of new information for you. That's why I kind of like this section, but it is the converse. So what we're going to do today, instead of starting with parallel lines, we prove the lines are parallel. So converse. So not a lot to write on the notes here, not a lot to write on the notes, but just a little bit here. So first things first on your notes. So it says point of the day. The first thing you need to fill in there. Everything we learned today will be proved 2 lines are parallel. All the blanks on that front page of your note, parallel. Okay, parallel. You're going to hear me say parallel like 50 times today. You're going to get sick of it. So point of the day. Everything we learned today will be to prove that 2 lines are parallel. Okay, so let's look at them. Let's talk about them. Corresponding angle. So this was our old theorem. 2 parallel lines cut by transversal, they're congruent. We just used that in the warm-up problem. Now, just to highlight it in red, we're going to use the converse. If the corresponding angles are congruent, then the lines are parallel. So we're doing the flip of it. If I can show the angles are congruent, then the lines are parallel. It's the reverse of what we did last week. Now that's going to be true for all of these, okay? We're just cycling through them all. Last week, if the lines are parallel, alternate interiors are congruent. This week, we're going to have the word converse on it. If alternate interior angles are congruent, then the lines are parallel. So you're going to hear me say parallel a lot today and converse a lot today. And of course, we got to go through the other ones, alternate exterior angles, so kind of the bottom of your notes. Of course, we know if you had parallel lines, the angles were congruent. Now we have the converse. If alternate exterior angles are congruent, then the lines are parallel. Key word of the day, parallel. I can't say it any more times than that. Okay, if you flip it, of course, we've got consecutive interior angles. That is the one that is not parallel. You know that. They're supplementary. So last week we gave you parallel lines and you knew those angles were supplementary. This week we're going to use the converse. If consecutive interior angles are supplementary, I know we're shocked, then the lines are parallel. Have I said converse and parallel enough? Okay, so a little bit similar, but a little backwards. Today we're going to try to show the lines are parallel. So when you look at this first example, notice there are no triangles on the lines. We do not know those are parallel. They look parallel, but I don't know that they're parallel. Find the value of x that makes them parallel. Okay, so I'm looking at my angles. We just reviewed this in the warm-up problems. What type of angles are those? What's their special name? Starts with a C. I think maybe said it. Corresponding. So, corresponding angles. Do they need to be congruent or supplementary? Congruent. So if I can make these angles congruent, which I sure can do, then our lines will be parallel. So we just have to solve for x. So I'm going to subtract 5. And you've got your final answer. So you might be asking yourself, well, how is this any different than anything that we just did? It's the wording in the directions, because you're finding the value that makes the angles congruent, that makes the lines parallel. Is the work the same? Yes, 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 but it's the difference in the directions today. All right, look at these pictures. Is there enough information to conclude that M is parallel to N? So notice, no triangles on the lines. I do not know that those are parallel. We're going to see if we can figure them out. First, I'm looking at the given angles. And I was like, well, 75, 105, there's not a direct relationship between them just as they stand. So I'm thinking no, but then I'm like, wait a minute. So I'm thinking about, if I know this is 105, I can get you this angle. Here's a pair that make a line. What type of angles are those? A pair that make a line? Linear pair. And a linear pair should add up to what? 180. So a little mental math here. If you have 105, how much more do you need to get to 180? Yeah. So I'm just going to put a little note here. How I got that 75 is these are a linear pair. Now I think I'm going to change my original thought of no. No, I thought no because I was like, well, these aren't anything special. Now I'm going to switch it to yes. Because now these are the same and they're corresponding. So if corresponding angles are congruent, then the lines are parallel. And that's exactly what we have. So I'm going to say, yes, they're parallel. And I'm going to say corresponding, I'm going to abbreviate, angle. Now, all last week I used the word theorem. I didn't care if you wrote the word theorem, remember, on the proofs. This is an important word, though, I have to write. This is the converse. If corresponding angles are congruent, then the lines are parallel. So we have to put that word converse on. Sorry for my sloppy handwriting. So same thing. We're just going to look at a couple more pictures here and then, so I'll do a little math and then we'll do some proofs, of course. All right, can you prove lines A and B are parallel? So again, no red triangles on them, but you have that these are congruent. Well, what type of angles are those with the congruent marks? What special pair are they? Notice your picture is a little slanted here. Our transversal's this guy, hitting the two lines. So if you rotate the picture, that's kind of how we're used to seeing it. What type of angles are they called when they're in similar locations? I heard it back there, corresponding. Corresponding angles congruent. Yep, that's what we've got. Lines are parallel. So I'm going to say, yes, I can prove it. And it's that same theorem, corresponding angle converse. Keyword converse, of course. I gotta scroll it down so we can see picture 2. Okay, let's look at 2. So of course this would be your transversal. The transversal is the line that intersects 2 or more. So I'm looking at the ones, mine are in red, of course. The red congruent ones. Are those red congruent angles a special type of angle? Oh, perfect, Parker. Alternate exterior. So yes, the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. So I'm going to say yes. This time I'm going to say alternate exterior angle. What's the final keyword on this? Converse. All right, the last one, let's look at picture 3. So again, same thing. Here's our transversal. Okay, so 1 and 2. What type of angles are 1 and 2? Alternate interior. Are they congruent? Are there actual congruent marks on there? No. They're in red, which I mean, great, mine are in red, cool, super cool. But there's no actual physical congruent marks on it. I cannot assume that those angles are congruent. So this one is a no. I don't have congruent marks on those. If I did, it would be a yes. I'm going to say angle 1 and angle 2 are not congruent. For my explanation, I'm not going to get any more fancy than that. Remember, we talk about that a lot here. Don't ever assume anything on the picture, even though they look congruent, they look it. Don't assume it unless you have the actual markings on it. All right, let's do some actual solving for a number here. Let's do some numbers and math. I know it's craziness. Find the value y that makes a parallel to b. So look at your angles. What type of special angles are these guys? Alternate exterior is always 50-50. Do they need to be congruent or supplementary? Congruent. So let's just set them equal. Okay, we're going to solve for y. We're going to subtract off 6. We'll be down to 115 over there. Here, of course, you would need your calculators. I'm going to get the calculator out. How many times does 5 go to 115? 23. Perfect. So today's kind of a mix of stuff. There's some obviously solving for a variable, a little actual math. There's some of that explain your answers. And of course, there are some proofs. Now, notice this is flipped of last week. Last week, I gave you parallel lines and you proved the angles were congruent. It was flipped around. So just take note of that. So given today, angle 4 is congruent to 5. Given. They even marked it on the picture for you, which is nice. So I'm looking at 4 and 5. What type of special angles are 4 and 5? Alternate interior. I think we got it in a 2-step proof. If alternate interior angles are congruent, which they are, then the lines are parallel. Bam. I love a 2-step proof on a Monday. Which is parallel to H. Alternate interior angle. Okay, do you need the word converse? Yes, when we prove lines are parallel, that is the converse of our original theorem. So that is the other key detail you have to take a quick, hard look out for today. All right, let's write another proof because why not, right? Okay, in the diagram, R is parallel to S. Okay, we got a lot of lines over here. You can see mine are marked in red on the triangles. So R parallel to S. Just to kind of highlight that for you. They didn't even give me my statements and reasons. Let's go on. All right, let's do the given. So in the diagram, R is parallel to S. And angle 1 is congruent to 3. Okay, I'm going to mark that in the picture here for us too in just a minute. Okay, they also tell you angle 1 is congruent to angle 3. So let's mark that. Okay, so you have to look closely at this picture. There's so many lines. So our parallel lines, we're used to them being these horizontal ones. It's like they rotated the picture. So you have 2 transversals in here. You have this guy and this one. So I'm looking at the green, the transversals. So I'm looking at these guys. And I'm like, well, okay, 1 and 2 are in similar locations. So 1 and 2 are going to be congruent. And of course, similar location corresponding. So let's put that in. Angle 1 is congruent to 2. 2 corresponding angles. Now, I don't need converse because we are not showing the parallel lines. We have parallel lines given. That is what making those angles congruent. So that's just the theorem. Okay, then I'm looking at what we all have here. I'm like, well, okay, 1's congruent to 3, 1's congruent to 2. I'm going to use our favorite transitive property where I get rid of these matching angle 1s and I just write down what's left. Angle 3 congruent to angle 2. We'll transitive. And let's look at the picture and see if that helps me. I think it will. So now we know, of course, you can see I've got the congruent marks on here, but I'm zeroed in on 3 and 2. So it's like, oh, okay, I like that. What type of angles are 3 and 2? Alternate interior. If alternate interior angles are congruent, then the lines are parallel. So P and Q are going to be parallel, those green dashed ones I have highlighted. So I'm going to say my lines are parallel for my step 4. So my P is parallel to Q. And that is because we had alternate interior angle. Is that theorem or converse? Converse. Good, Cass, because we're showing the lines are parallel. Now, again, like on reason 2, I won't be upset if you don't have the word theorem on there. That's fine. I will be upset if you don't have converse, though, on reason 4. So just make sure when you're showing lines are parallel, that's your converse, okay? All right, last thing I have for you, this is some easy stuff. Okay. So transitive property of parallel lines. To me, this is one of these many theorems of geometry. I just read it as like, well, yeah, that makes sense. If two lines are parallel to the same line, then they're parallel to each other. Yeah. If P is parallel to Q, Q is parallel to R, P is parallel to R. Aren't they all parallel? It's just the whole world of parallel. Everything's parallel. So, look at the flag here. Flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below. Explain why the top stripe is parallel to the bottom stripe. Okay, all right. So if you really want to get detailed on this, I was like, okay, S1 is going to be parallel to S2. S2 is going to be parallel to S3. I mean, I can keep going. This is obnoxious, I know. We can get rid of those S2s, and now I'm down to S1s parallel to S3. I can keep doing this all the way down the line, and won't I eventually have S1s parallel to the 13th one? We just keep writing it out and using all this transitive property. So I'm not going to get carried away. Explain why the top stripe is going to be parallel to the bottom. That's just that transitive property of parallel lines. I mean, they're all parallel to each other. Of course, the top one's going to be parallel to the bottom one. The middle is parallel to the bottom one. The second is parallel to the bottom one. They're all parallel. That's that transitive property parallel. I don't think we need to talk about that anymore. Okay, little ACT practice, a little standardized testing practice. We might need a calculator for this one. A hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in 1 2 decagram container? Man, that's wordy. And this is something that's really easy. You just got to do a little bit of conversions. So first off, I'm seeing this 2 decagrams. Well, if you know 1 decagram is 10 grams, 2 decagrams is how many grams? If 1 is 10, 2 is 20. Okay. Just a little mental math there. Now, they want to know here how many milligrams is my final answer. Well, if you have 20 grams, if 1 gram is 1,000, 20 grams is 20,000. So it's just doing a little converting off the little box there. I feel like I'm teaching science class right now. Okay.